Hello and thank you for watching. In this video we're going to give an epsilon-delta proof of the limit of a square root. Okay, so to jump right in, let's say we wanted to prove that as x goes to 4, square root of x, this is equal to 2. So first off, we start this like any other epsilon delta proof. First we want to do some scratch work to find out what we want. So from definition we know that modulus of x minus 4 is less than delta should imply that square root of x minus 2 is less than epsilon in some way. So we're going to try to find something to go from this to this for some given epsilon. Okay. So notice that this is just the square root of this. So if we recall that if we have a squared minus b squared being equal to a minus b times a plus b, it seems like a good idea to try to multiply this by root x plus 2. However, we don't want to change this, so if we multiply it by root x plus 2 over root x plus 2, we're essentially multiplying by 1, so nothing on the right hand side changes. However, this is equal to x minus 4 over root x plus 2. Okay, so now we see, nice, we've got this x minus 4 that we wanted. However, we've still got this root x plus 2. But our x is a positive. So we know that we're adding some positive value to this too. So we know that if we have 1 over root x plus 2, this has to be smaller than a half. So that concludes our scratch work. And so we will set our delta equal to 2 epsilon. Okay, so now here comes the proof. Proof. Suppose that epsilon is greater than 0, then if 0 is less than the modulus of x minus 4 then 2 epsilon, then we have that root x minus 2 is less than epsilon. So we're trying to go from this step to this step. So we're saying that then we have root this, and then, okay, what did we do here? When we multiply by 1 over square root of x plus 2 over square root x plus 2, oops, this is less than 2 epsilon times 1/2, and so we have square root x minus 2 being less than epsilon. Therefore, so if we have that the modulus of x minus 4 is less than 2 epsilon, then we have that the modulus of square root of x minus 2 is less than epsilon. So we know that the limit as x goes to 4 of square root x equals 2. Okay, I will do one more example of this. I'll do the exact same thing, just to have multiple examples out there, and then I will give the viewer some exercises. Let's go to 9 this time. Square root of x, and we want to prove that this is equal to 3. So again, we want to have some x minus 9 less than delta, and we want to have some square root of x minus 3 less than epsilon. So then multiplying by 1 in a way such that we can achieve our left hand side, so we can achieve this, we get that x minus 9 over square root x plus 3 is less than epsilon. We just utilize the difference of two squares again. We utilize this over here. And so, okay, this 1 over square root of x plus 3, this is a positive, we're adding a positive number to 3, so we know that, oops, this is less than a third, and so we will set our delta equal to 3 epsilon this time. Okay, now proof once more. Proof. Suppose epsilon is greater than 0. Now, say that modulus of x minus 9 is less than 3 epsilon. Then we have x minus 9 over modulus of square root of x plus 3 is less than 3 epsilon multiplied by a third. So we have that the square root of x minus 3 is less than epsilon. Therefore, if we have that modulus of x minus 9 is less than 2 epsilon, then square root of x minus 3, oh, 3 epsilon here, 3 epsilon is less than epsilon. So we have that, hence the limit as x goes to 9 of square root x equals 3. Okay, hopefully those made sense. I know I went through the second example a bit faster, but it's just synonymous to the first example, so if it was too fast, then maybe look at the first example once more before going back to the second example. Okay, now for some exercises. The first exercise is going to be prove that the limit as x goes to 4 of, well, not 4, to 16 of square root x equals 4. Second exercise, prove that limit as x goes to a squared of square root x equals a. Third exercise, prove, this one's a little bit harder, so I'll add a star as a challenge exercise. Prove that the limit as x goes to 8 of x to the 1 over 3, so the cube root equals 2. This one's also going to be a bit harder. prove that the limit as x goes to a to the n of x to the 1 over n equals a. This one's, I'll add a double stuff for this one because it's quite a bit harder. And as a hint for those, I will write that we have square root, and not square root, the sum from k equals 0 to n minus 1 of x minus nk yk multiplied by x minus y equals x to the n minus y to the n. Okay. Oh, x to the n minus 1, sorry, there should be a minus 1 here. Okay, thanks for watching. That's the end of the video. Hopefully this helped you understand helped you understand epsilon delta even further. Bye bye.